Welcome everybody to taking a look at multiplying and dividing common bases. This is Chapter 5. Chapter 5 talks about polynomials and properties of exponents. We're going to start talking about exponents first, and after we talk about exponents, we're going to talk about polynomials. The reason we talk about exponents is because with exponential terms are going to be used quite a bit in polynomials and future, so we just talk about polynomials just in general to start us off. So first things we're going to do in this video, two things. Number one is review exponential notation, just what notation is, what it looks like, what the terminology is, and then kind of do some evaluation of expressions with exponents. We're going to, later on, we'll talk about multiplying and dividing. Later on, we'll talk about simplifying expressions. Later on, applications. But right now, we're just going to kind of talk about the basics of multiplying and dividing common bases, and we're just reviewing exponential notation, just these two things right here. So we have, in Chapter 4, we talked about x and y ordered pairs. So that was Chapter 4. We did that, kind of done with that, and we're kind of moving on to away from linear equations and more towards polynomials. So we're going to get towards polynomials in probably the end of this chapter. And in order to work with polynomials, multiplying, dividing, things like that, we have to really talk about the exponents. So that's kind of what we're going to do today, is just talk about exponents. And I put up the Eiffel Tower here just because when we're leaving, or sorry, when we're in a land, we need to talk the language. So this is the language of French. I know a little bit of French, and so we need to really talk about polynomials and exponents. So let's talk about just the terminology of what is an exponent. So if we talk about an exponential notation or exponential term, we talk about a base to the nth power, and this is just in general what a base is. The base is the number that's multiplied together. The n is the exponent. That tells you a specific information, a specific piece of information about that exponential term. So again, a base taken to an exponent. Here's the exponent. Exponent is n. B is base. So let's take a look at kind of applying that and talking about it. So again, I'm just going to reiterate what I said before. Here's our base, here's our exponent. We're going to again talk about the base to an exponent. So what does that mean, base to the exponent? If we've got b to the nth power right here, and we're talking b to the nth power, I'm going to rewrite it here because it's a little bit small here. B to the nth power just basically means that we're taking b, our base, and we're multiplying it by itself n times. So all these b's multiplied together n times is written in shorthand as b to the nth power. So b to the nth power talks about b times b times b n times. And if that's kind of a takeaway. So if you're looking for adding something to the cheat sheet or the study guide, that's something that's going to be just a good definition to remember. So let's take a look at just some examples of what the base is and what the exponent is. So if we're talking about bases, we're talking about exponents. Let's just talk about what these are. I'm going to do one of these, and I'm going to actually ask as another question probably, what's the value? Let's evaluate these as well. We can do that. But the first thing we do is take a look at 6 squared. Our first example here is 6 squared. So what's our base? Our base is 6, because that's, if you take a look at the example of an exponential notation here, base to the exponent, b to the nth power. Our b is the base, 6 is our base, and our exponent then has to be 2, because that's the number that we're taking that to. So what would be the value of this? Let's take a look at the value and say, what's the value? Well, if we write it out longhand, it would be 6 times 6, because we're multiplying 6, our base, 2 times together. So it'd be 6 times 6. What is the value? 36. So I'm going to ask you guys to pause the video and just kind of take a look at the rest of these examples down here and get some ideas about what they would be. So pause the video, take a look at it in your own mind with your own calculator, and we'll talk in just a second. Alright, so what's the base? For this example here, what's our base? Our base is whatever's inside the parentheses. We'll take a look at specifically negative numbers later on, but the base here is negative 1/2, because the negative 1/2 is inside parentheses. That 3 is acting on the negative 1/2. So what's our exponent here? Our exponent would be 3. So let's try to evaluate that or find a value. What you'd have to do is you'd have to write negative 1/2, because that's our base, multiplied by negative 1/2, multiplied by negative 1/2, again, because that's our base. Our base is negative 1/2. It's inside the parentheses, so that has to be our base. Multiplying it 3 times, because that's our exponent. Multiplying it 3 times by itself, and that's our exponential, or the exponent tells us to do that. So negative 1/2 times negative 1/2 times negative 1/2 is negative 1/8, and that would be our answer. Let's see, what's our base for the next one? 0.8. What is our exponent? Our exponent is going to be 4, so the longhand would be 0.8 times 0.8 times 0.8 times 0.8. And if we evaluate that, we'd have to use the calculator, and we'd say 0.8 to the 4th power, or 0.8 times 0.8 times 0.8 times 0.8 gives us an answer of 0.4096. That's our answer for that one. Next two are a little bit tricky, only because we talk about a base and an exponent. What's the base? What's the exponent? Here, if we've got an x, or if we've got any variable, and there is nothing written as an exponent, we have to assume that the exponent is 1. So it's kind of like if there's no number in front of the x, we have to assume it's a 1. If there's no sign in front of the x, we have to assume it's a plus. So we have to assume that if x is just written by itself, then the power is 1. So what's our base? So I guess we have to rewrite this again, x to the 1st power. What's our base? Base is x. What's our power? What's our exponent? Exponent is 1. So there's our evaluation, and here's what's our evaluation of x to the 1st power? It's just x, not written, not multiplied by anything else. And we can't really evaluate that because we don't know what x is, but as far as the value goes, that's just the value. Take a look at the next one. This is 3 times y to the 5th power. Keep in mind that this would be just simply 3 times y to the 5th power. So that would mean that this part over here, the y to the 5th power, that's an exponential term. And I should clarify that. There's a 5 right there. That's a 5. So this is 3 times y to the 5th power. Again, the 3, if there's no exponent written above it, we have to assume it's of 1. So there's 3 to the 1st power times y to the 5th power. And we would have to rewrite it as longhand. I suppose if we fill our form in up here, what's the base? If we're talking about just the exponential term, y would be our base for the exponential term because it's y to the 5th power. 3 is just a number. It's 3 to the 1st power. But if we're talking about the exponential term, it's y to the 5th power. It's y is our base. Exponent would be 5. And if we write it out longhand down here, it'd be 3 times y times y times y times y times y. And there's 5 y's together because it's y to the 5th power. And that would be our evaluation. That would simply be our evaluation. We don't know what y is, so we can't really say an example of what the value would be. So there's just some terminology and some ways to remember things. Remember, write down your questions, bring them to class.